Today I would like to introduce to you this YDJ-15kVA/200kV AC/DC Hipot test set. Now let's introduce the AC test of this AC/DC Hipot test set. It can rise up to 200 kV. First, power the instrument with a 380 V power supply. Here is the 3-phase 380 V power input. This is the input from the console to the test transformer. This is a ground terminal. These two green ones are measurement terminals. This is an output terminal. They correspond to the grounding on our test transformer. Then it's measurement and an input terminal on the test transformer. Output terminals on the console, through the red line. Then connected to the input terminal of the test transformer, the red one here. These two are the measuring terminals of the instrument. They are also the two wires of the console. Connect to the measuring terminals on the test transformer. These three wires are all grounded. The three are connected together. Then this black wire is the ground wire of the console. Connect here. This wire is connected to the ground wire. Must be well grounded. Turn on now. Then the indicator light will light up. Here is the zero indicator light. When this place reaches 0, it will light up. If it is not reset to 0, it will not light up. Now turn on one of its boost switches. The instrument enters the high voltage pass state. Then we adjust this knob. Increase the voltage of the instrument. Can be seen, now it has been increased to 50 kV. This is the voltage display. The current voltage has reached 50 kV. Okay, let's go up again. You can see that it has reached 100 kV. Due to time constraints, here won't do more demonstrations. Now after 100 kV, we set the timer here. Turn on the timing switch. Start the timer. When the time is up, it will automatically alarm. Due to time constraints, I won't give you a demonstration here. When the time is up, we'll just turn it off. Then reset the knob of the instrument to 0. After returning to 0 position, it can't turn here anymore. Then disconnect the high voltage. Here is the 0 position. High voltage has been disconnected. After the test is completed, we must disconnect the power supply. Then discharge. Disconnect the power. Perform discharge. The power is now disconnected. We discharge it. Next, I will introduce to you this YDJ-15kVA/200kV AC/DC Hipot test set. Now let's introduce its DC connection method. Its DC connection method can increase the DC power up to 280 kV. Our instrument first uses a 380 V power supply to power it. The functions and distribution of these wiring terminals will not be described again. When we do the DC withstand voltage test, install a grading ring on the top of the experimental variable, and then connect the silicon stack rod and the grading ring. And then to one of our silicon stack rods. Be careful not to install the silicon stack rod backwards. Must follow this direction. Then connect the grading ring. Connect to the test object at the intersection of the brackets. Do experiments on the test object. This pillar mainly plays an insulating and supporting role. Put it up. What we must pay attention to here is that this place must not be connected backwards. Follow our arrows. Just follow the direction we are pointing to connect the wires. Be sure not to connect it backwards. And then come here again. An insulating stand over here. What we installed here is a grading ring. Then the test object can be connected from this place. This bracket mainly plays a supporting role. Then connect the ground wire to the bottom of the bracket. Inside the grating ring, we can see that this is a supporting iron piece, and then connect it to our insulating rod bracket. From here, it can be directly connected to our test object. Then conduct an experiment. Give it a support, put it up. It is best that the bottom of this insulating bracket should be reliably grounded. During the test, we turn on the switch of the instrument. This is the power button and zero signal. After we reach the zero position signal light will turn on. Normally, the power supply will light up after powering on. Now all we need to do is turn on the normal high voltage switch. Then click high voltage pass. You can see that the boost signal is now reflected. Then we will directly increase the voltage now. Because of time constraints, here won't go up too high. After the boost process is completed, we can click on a timer. After the timer expires, just turn it off. Good timing done, we turn off the voltage. Then click on a high voltage disconnect. Okay, that's it now. After shutting down, then close our circuit breaker. Discharge finally. Test completed. Discharge the instrument.